Abdul, are you there? Abdul?
Yeah, yes, I am available.
Okay. So my screen is visible to you, right?
Yes, sir, it is visible.
Yes, yes. Thank you. So we'll be discussing actually, yesterday we had a class, and that day I ensured that we will be discussing the questions, MCQ questions, this in this session, this 2 hour session. So it will be a comprehensive, and most of the question we will try to cover. So and after that, at a certain point of time, and I think it will be not a not that huge task to do that. I'll be giving you questions, and okay, I'll be just list down the questions and answers. Okay, probable answers, and you can try on your own later in later days after your examination got over, because these are the questions, these are universal questions, and these are is very much relevant in terms of competitive exams or in terms of knowledge enhancement. So all these things, for all these things, these questions are beneficial, very beneficial. So actually we have covered till 80. Now we'll be going forward from 81. Okay, so what is the says? What it says, the maximum shrinkage takes place in the concrete after drying for how many days? Maximum shrinkage, 28 days, 3 months, 6 months, 1 year. Okay, so actually this shrinkage means uh, when after the shrinkage takes place because of the dryness, and yeah, and because when the this water in the pores, gel pore, get out of the concrete system, and it can be possible that if it's in some dry area, then with progress in time or progress in hydration process, so this gel, this in particular, this water can get out of system. Okay, so if there is some entrapment is there, means the water can't get out from the system, then also water can be used in hydration. So either way the water will be get out, and the thing is that if in the drying sinkage means water is getting evaporated to outer atmosphere. Okay, so that's why it getting some tensile stresses are developed, and that's why these stresses are coming, extra stresses are coming. Okay, so I think we have already discussed this mechanism in our previous classes and also lectures. So and due to that, this cracks can occur. So maximum shrinkage takes place in the concrete after drying, for how many days? So I think it is maximum. So let's check what it is. This the rate of shrinkage, actually it says that rate of shrinkage decreases, and the rate of shrinkage decreases rapidly with time. It is observed that 14 to 34% shrinkage occur in 2 weeks, 40 to 80% of shrinkage occur in 3 months. Okay, it's natural, right? So whenever you increase the days, the shrinkage rate will be much higher. Shrinkage quantity, the percentage of shrinkage will be much higher, because more water will be consumed, more water will be get evaporated out, or out of gel system, and due to that the shrinkage will propagate, the shrinkage will fall, enhance, and there'll be some increase in uh, shrinkage tendency. So at the end of the 1 year, rate of shrinkage reduces to half of its value. Okay, so and after that, whenever at a certain particular peak, at a certain particular point in time, and this percentage shrinkage get a peak value. After that, it reduces, and after 1 year, it says that it is the shrinkage reduces to half of its initial value. In the from the value it started to get, and started it's the starting value, initial value, it become half at the end of 1 year. So with that increase in time, we are seeing that the shrinkage rate is reduced. shrinkage rate of shrinkage get reduced. So it's obvious 40 to 80% shrinkage occur in 3 months. So 3 months, actually this is the right choice. So I am writing here. Okay, I'm writing here. So 3 months. 3 months is right. Yeah? So I'm writing here. Okay, so I can write here.
This 3 months means 30 to 40% it is attained, isn't it?
Yes, yes, yes. 30 to 40%. 30 to 40% shrinkage is taking place. So they are saying that it is rate. The how much percentage rate is changing, percentage changing in shrinkage quantity. So it is 40 to 80% shrinkage is is occurring in 3 months. 14 to 34% occurring in 2 weeks. Okay, and the initial it starts with the value and get half of it at the end of 1 year. So that's how this shrinkage is quantified. And so I'm writing here. Actually, I should. So actually, it says the shrinkage rate. Actually, shrinkage rate. Shrinkage rate rapidly decrease with time. Decreases with time. How much it is? 14 to 14% to 34% shrinkage. Occurs in two uh, 2 weeks. In 2 weeks, 40 to 80% shrinkage occurs in 3 months, and in 1 year, the shrinkage rate equal to the half of the shrinkage rate shrinkage rate at initial stage. At initial stage, after just after it got hardened from plastic to hardened state, from that instant of time at initial age. So these are the statistics. So yes. So under the second question is under constant load, the creep strain in concrete is time dependent, temperature dependent, moisture dependent. See, it is mostly the time dependent, right? So under constant load, the creep strain is time dependent. Is temperature also give some effect of it on it. However, the time is the more relevant. So is actually is time. So creep can be defined as the time dependent strain under constant effective stress. Yes, the temperature load is, see, this is the criteria that when if the temperature is coming in between. So the main criteria is the time. With the time, if the temperature get added also in the in between, the temperature not coming or if the temperature condition become a prevailing scenario, then it will just accelerate the creep rate will become, the creep strain become accelerate, value become higher. So the main idea is the time dependent. So you are the creep. The concept of the creep is you are applying a constant load, or you are get observing that how much deformation taking place in particular section, concrete section or any other structure. So actually, it can be said the relative motion between the between two layers or between the layers of the uh, structural section. So it's the time is the very relevant for it. Actually, it's take very large time. So time is the most appropriate answer here. Okay. Just a minute. So this is the time is the most appropriate. Actually, I can't. Actually, it should this marker should come actually. Yes, it came. This is this time dependent. This is the most dependent. So lightweight concrete, we have already understood the what is the lightweight concrete, how the lightweight concrete are manufactured with the help of the air entrainment or autoclave mechanism, autoclave test or autoclave mechanism. You are introducing fly ash inside it so that and you are increasing the void space. Okay. So the lightweight concrete is prepared by using lightweight aggregate, formation of air voids in the cement by omitting sand, formation of the air voids in the cement paste by the substances causing the foam. Yes, already the foaming agent also there. Aluminium foam is also there. We've already discussed this previous class only. This previous to previous class. Yes, I think previous to previous lightweight concrete. Yes.
That means all options are correct.
All options are correct. Mhm. Yes, this previous class only. The all options are correct. So what is it says 83, 83, 83. Yes, all options are correct. The addition of calcium chloride in the concrete results in increased strength, reduction in calcium chloride. Calcium chloride, I think it is retardation, reducing curing period, retardation of the loss of moisture. All options are correct. So what it says, actually calcium chloride is an accelerating admixture. Yes, calcium chloride CaCl2. CaCl2 is a accelerating admixture used in the concrete. From the practical point of view, the calcium chloride results in reduction in curing point. Obviously, the accelerator, this it is accelerating admixture means it is reducing the curing period. Reducing the period, a retardation of the loss of moisture and so reduction in curing period get reduced and reduction in time during which this concrete must be protected in cold weather. So and earlier finishing, when there is earlier finishing is a criteria, and in the cold weather condition the construction is taking place there, then there this such type of calcium chloride can be introduced. So mainly it is in the purpose of the reduction of the curing period. Okay, so 84 is B. The modulus of elasticity of concrete improves by shorter curing period, age, higher W by C ratio, WC ratio, water cement ratio, and all option correct. So see, the higher W by water cement ratio is not correct. The higher water cement ratio means lower strength. Lower strength means lower elasticity. Not the shorter curing period also it can't gain strength because of the yeah, not sufficient um, hydration and not uh, what can I say this required hydration. The hydration that should take place, you are not allowing that to happen. Then it is a little shorter curing period. Then it can't get the full strength uh, to till that date only from the casting period. So I think it is age improves with the age. But however, if we see that with the age, the hydration still going on, and with the age, this is C3S giving the ultimate strength. Okay, initial strength is low, but it is the ultimate strength, I think is high, giving the ultimate strength to the concrete. So with this particular properties, this the hydration get keep on continuing with the age, and the concrete thus gaining strength. So it is a shorter this age. Mostly it is age. Yes, it is age. So the modulus of elasticity increases as the strength of the concrete increases, and strength of the concrete increases as it at it ages, means uh, with with time. So here is right option. The minimum number of test specimen required for finding compressive strength of the concrete is minimum 3. I think 3. Actually IS 456, IS 456 clause 5.4.1.2. What it says yes, it is already there actually. 5.4.1.2, right? What it says. Yes. What it says, this average 28 days compressive strength of the concrete strength at least three at least three 150 concrete cubes. Actually, this is the sample size 150 110 concrete cube prepared with water proposed to be used shall not be less than 90% of the average strength of the three similar. Actually, this is all this closely resembles this this characteristic strength, where the 5 percentile, the 5 percentage, not more than 5 percentage is less than this value. So that's why it says that not less than 90% of the average strength of the three similar cubes. Um, yes, should not be less than 90% of the average of strength of three similar concrete cubes prepared with the distilled water. The cubes shall be prepared, cured, and tested in accordance with the requirement of IS 516. So IS 516 tells the curing methodology and testing methodology. So what it says that 28 is compressive strength of at least three cube samples prepared with water proposed to be used shall not be less than 90% of the average um, of the average of the strength of the three similar concrete cubes with distilled water. So you make it with the plain water, and you are making with the distilled water, three distilled waters, and from the distilled water, the concrete, if you make it average and you get some average value with the distilled water, the value are getting, and value are getting with using the normal water, where the minerals are there. In the distilled water, no minerals are there. Okay, so that is the thing. No minerals are there, and with normal water, how much you are getting, you are get an idea, and you compare these two values. So this and it says that 90 shall not be less than 90% of the average. Yes, 90% of the average means with distilled water, what you are getting something X distilled or F distilled equal to or you are getting with the normal water if FW. So FW should be should not be less than, FW should not be less than 0.9 F distill, should not be less than 0.9 F distill. Okay, so this is the FW, means this average cube strength made with normal water. This is distilled average cube strength. All are samples with 150 mm cube size. Okay, so average cube strength made with distilled water. Okay, so the FW should not be less than 90% of the F distilled. So, so this is the criteria, and it all are 28 days. Are measured at the strength are measured at 28 days. So it is IS 456 2000 clause 5.4.1.2, and after that the cube should be tested in accordance with IS 516. It tells that curing and testing methodology, testing process. Okay, so IS 516. Yes. So now, yes, yes. So it is three. Is three. So it is six. It is three. Yes, it's A. So now 87. 87. What is a two weight concrete may cause segregation, lower density, weakness of concrete. All options correct. Yes, segregation is all options are correct. It's very natural. Two weight concrete results in higher content of water. What is if the higher content is higher, then there'll be leaching of water and the leaching of cement paste from the solid element. Solid element is coarse aggregate. Coarse aggregate set aside, and the paste will be separated out. So there will be no bond actually. So lower density and also reduces strength. So actually, what it is D. I've written D. And now the curing period is minimum for concrete using rapid hardening cement, low heat cement, ordinary Portland cement, slag cement. See, this slag, ordinary, low heat cement means the all three allow the hydration to get delayed. Okay, so so all three are very, so right. I'm trying to say that yes, it is rapid hardening cement. Yes, so low heat cement. If you introduce the low heat cement, then it allows the concrete to get hardened slowly. Ordinary Portland cement is average, and slag cement also is like Puzzola material. It also giving some retardation in um, hardening, in a hydration process. So rapid hardening agent is right answer. Now the 50 kg, and now there is some design problem. I think yes. Yes. The design thing is if 50 kg of fine aggregate and 100 kg of coarse aggregate are mixed in a concrete whose water to cement ratio is 0.6. Okay, water cement ratio 0.6, and weight of the water required for harsh mix. What is the water required for the harsh mix? Okay, so 50 kg fine, 100 kg coarse aggregate. 50 kg, the fine aggregate is 50 kg, coarse aggregate content is 100 kg, water to cement ratio is 0.6, right? Is 0.6. Now, how we can how we can quantify the weight of the water for making harsh mix? For harsh mix, it says water weight of water liquid. Water liquid water liquid is this 30% weight of fine aggregate plus 5% weight of coarse aggregate and water cement. So I think these are all the trial are done, and this way they are the researcher or the industrialist come to this point. Okay, so actually there is no code standard. Is water cement ratio. What is the water cement ratio? The 30% is fine aggregate 50 plus 5% of coarse aggregate water cement is 0.6. So it tells that 30% is 15, 5, 15 plus 20, 20 into 6, 12 kg. 12. So it is 12 kg. It is 12 kg. If in a mix, if desired slump is not obtained, the adjustment for each concrete slump difference is made by adjusting water content by what? So in a mix, if the desired slump is not getting, one is not getting the desired slump, so adjustment of each concrete slump difference, adjustment of each concrete slump difference is made by adjusting water content of how much. So you are adding some water and from the to the existing water. So what it says actually is a very specific value rule, and there is no calculation actually. So just with the trial they are making statements. So it is 90. It says B. So the adjustment of each concrete slump difference is made by adjusting water content by 0.25%. Okay, so 0.25% water you are keep on changing, giving. Okay. So you are adjusting the slump. Each adjustment is taken care by adjusting the water content by 20.25%. So this is the 90. Okay. Now the 91. 91 says that in a case of hand mixing of concrete, the extra cement to be added is, I think, is already we have studied this value. The value is very specific, and there is no detailed discussion. Is no detailed discussion on it. Just and there's facts and figures. Okay. 91. 91 it says B 10%. In case of hand mixing of the concrete, the extra cement to be added is 10%. Okay, 10% of the concrete volume. Okay, so the separation of the water from fresh concrete is called the bleeding, right? We all know the bleeding is an undesirable process of mixing water, separating from the fresh concrete waste or the concrete while it is being placed or so consolidated. So these are very common statement. So this bleeding. Bleeding. So say strength of the concrete shows an increase with what? Decrease in loading, rate of loading, increase in rate of loading, unaffected by rate of loading, depends on application of load. Actually, increase in rate of loading is the most relevant one. Yes, it's actually B answer. The compressive strength of the concrete increases with rate of loading. You can test it with the normal UTM test. You change the rate to some certain value, and you compare the strength you are getting from the lower loading rate. You'll obviously get uh, obviously get the higher value for higher loading rate, because this higher value you are giving is more jerk on it. Okay, more jerk on it. So at initial stages, it shows this behavior of is yeah, these concrete blocks are reacting fast. So actually it actually is pseudo strength, so it's not actual actually. So it actually IS 456 and the other standards also available, which particularly mentions the loading rate. So this loading rate you test it, then only you'll get the right answer, and it should be eligible and should be, and that strength is applicable for design purpose. So you can't exceed that loading rate for a normal concrete mix. For the for the high strength concrete mix, there is some loading rate, there is some criteria also different based on the uh, design scenario or application scenario, applicability. Based on its applicability, you are changing the loading rate, and there is all designer specifications, or how the designers want to design the concrete, design the mix, and based on the structural functionality, structural function, or based on the loads, how much it's taking the loads, whether it is dam-like structure is taking the water load, or is some live load is there, some rolling load is there. So based on several criteria, it it gives these benchmarks. So the loading rate. So loading is very sensitive in case you are finding the strength. So loading is very sensitive. So so it is loading rate. Yes. Now what is it? Is 94. 94 says if the slump of the concrete mix is 60 mm, is workability low, high, very high, medium. Okay, so these are the very common problem and common values. So I'll just write down the ranges, so you can easily identify the things. So IS 456 clause, IS 456 2000 clause 7.1. It says the slump value and workability 25 to 50 mm. Workability is low, 50 to 100 mm. Workability is medium, 100 to 50, 100 to 150 is high, greater than 150 is very high. So these are the things. Okay. Now, so what is 62? 60 mm. So I think this medium is the right one. Medium. So segregation is responsible for honeycomb strata concrete, porous layered concrete, sand streak concrete in the sand streaks in the concrete. So all are correct. Actually, should be all are correct. Yes, indeed. See, all are correct means this if the segregation takes place. Segregation means this paste are going out, or the solid remain behind. So what happened? This honeycomb structure will form. So just coat segregate will get attached with it, and this honeycomb structure. Porous structure is for honeycomb is porous also. It's giving some porosity. It porosity it enlarged and enlarged. And sand streak means at some part of the concrete, if you are just scanning it, is take that the sand is finally get aside to one side, so it is taking, or it is heaping up to one side. So all are the symptoms of the segregations. Now the durability of the concrete is affected by cider, vinegar, alcohol, both cider and vinegar. So these are the more chemical background people are very much familiar with it. So there is no specific there is no such discussion. It's basically the chemical property of the material. So it is cider and vinegar contains acetic acid. Cider and vinegar contains acetic acid, which is responsible for disintegration of the concrete, thereby affecting the durability. So it says the vinegar. You just check it from internet what the not the actually the scientific name of the cider and vinegar. Also, its chemical composition. Currently, I'm not remembering. Vinegar. Vinegar has acetic acid. Acetic acid, and this is responsible for disintegration of disintegration of disintegration of concrete. So thereby affecting the durability. Thereby affecting durability. Okay, so these are the two. Now, so it is both vinegar and uh, 96, right? Yes, D. G. This is yes. The SLAM test is a measure of tensile strength, compressive strength, impact value, and consistency. Mm, and this strength suggestion is not correct. Compressive strength is not correct. Impact value, not consistency can be said. Workability. Yes, the SAM test is a measure of consistency of the fresh concrete mix. This is in plastic state mix, which in turn determines the workability of the concrete. And the higher the consistency, more the workable. So higher the consistency, higher the consistency, workability also more. Shrinkage of the concrete is directly proportional to cement content, sand content, aggregate content, temperature of the water. The cement content actually. Yes, with increasing cement content, cement is very fine. Okay, so if fineness is getting increased, then also then only this they consume the water very large quantity, and with the consume of water, the water get just empty, get died out from the concrete system, and due to that sinkage occurs. Okay, so cement content. Now 99. The appropriate value of the sinkage strength in the concrete, what it is. So clause 6.2.4. 6.2.4 is sinkage, yes. So this 6.2.4 IS 456 6.2.4. The total sinkage of the concrete depends upon the constituent of the concrete, size of the member, and environmental conditions. For a given humidity and temperature conditions, the total sinkage of the concrete is not influenced by the total amount of water present in the concrete system at the time of mixing, and to a lesser content by the cement content. Okay, so given the humidity, total sinkage is the most influenced by the total amount of water. So how much the water present in the concrete system at the time of mixing. So bidding me how much water content is present, and to a lesser content by the cement content, and to a lesser extent by cement content. Okay, so if the cement mm, if the cement is said, if you consider the cement content, then this is a lesser content, lesser extent. You are judging. You are not. You are more concerned about the water content. So, but given into temperature, the total shrinkage is most influenced. So, water present in the concrete system is the most influencing factor rather than the cement content. Okay. And in the absence of data, test data, approximate value of total shrinkage strain for design may be taken as 0.0003. So you can also refer IS 1343 for the particular insight. IS 1343. You can you can check this, check the details of it. So 0.0003. So this P. See, okay. Now 100. What is the question? Which of the following of the properties of a plastic concrete is modified by air entering agent? So it is workability, segregation, bleeding, okay, modified. Let's see what is they saying. Is D actually. Air entering admixture affects the very widely on the properties of the concrete. The slump of value of concrete increases with the air entering admixture. Using 1% air entering admixture, the slump value increases 10 to 15 millimeters. So it says this for 1% of air entering agent entrainment, 1% of air entrainment, it gives increase of slum value, slum value get increased positive by 10 to 15 millimeter. When the slump value increases, then this means the workability of the concrete also gets also improve, and by increasing air content naturally air content from the naturally occurring air, then required amount of water will also decline, and thus the bleeding and segregation will also get reduced. Okay, so required water also get declined, and the bleeding as the water getting reduced, requirement of water getting reduced, then the segregation, chances of segregation and bleeding also get reduced. So these are the influences. So if I say this, which of the following properties of the concrete is modified? So all these properties are getting modified. Okay, so this workability, segregation, bleeding, these properties are getting modified. So that uh, all option is correct. So a concrete in which the dry concrete segregate are first packed to have the least void, and then the cements and mortars is injected under the pressure to fill the voids, resulting a very dense concrete. Is called the pre-packed vacuum concrete, no fines, okay, and aerated concrete. What is this? Dry core segregate are fastly packed to have the least waste content, and then the cement and mortar are injected. What is called? Actually, it is it should be pre-packed concrete. Pre-packed. Let's check what they're saying. Yes, it is pre-packed concrete. Pre-packet concrete. For protection from frost, the second 102nd question. For protection from frost, the concrete should be dense, free from cracks. Adhesion between mortar and aggregate should be perfect. So all options should be correct because denseness should be there. Okay, and free from cracks. So the cracks should not be there. If there is a crack, then there'll be some ingress of water inside it, and if the ingress of water is there, and if it get frozen, then the ice, the volume of it will get increased, and it will just impart more pressure into it, and thus the crack will start to propagate, and get um, crack rate will get higher. Addition between motor and aggregate should be perfect. So these are all relevant points. So it should be, let's see, it should be D. It should be, and it is D. In order to have the segregation in the concrete dropping, I actually it's 50. We have actually studied this thing in our session, and also Professor Bhattacharya. There's are lots of theories are there. Some are says and this, some say that. So, and you just remember that I just show you, uh, considering the Professor Bhattacharya lecture, and for the this competitive exam purpose, this value are very relevant. And 103, it says that actually IS 456 2000 13.2 clause, 13.2 clause. Is placing of concrete. Okay, so placing of concrete, yes, the concrete shall be deposited. So first I write this the clause, this placing of concrete. So placing of concrete, placing of concrete. Concrete is this IS 456 clause, clause 13.2. Okay, so concrete shall be deposited as nearly as practicable in its final position to avoid rehandling. And the concrete shall be placed and compacted before initial setting of the concrete commences. Okay, so it shall be set. The initial setting should be there, and should be placed properly, and should not be subsequently disturbed. Method of placing should be such that to preclude the to arrest the segregation. This preclude means is arrest the segregation, and care should be taken to avoid displacement of the reinforcement or movement of framework. So whenever you are placing reinforcement, displacement of reinforcement should not be, position of the reinforcement should not be disturbed, or the form work should not be disturbed. Otherwise, the section will get hampered. And hence supposed, or the requirement. Actually, it will be a massacre. If the say, form work get disturbed, um, you can also see in the industry and the building construction, the errors are building the human errors. Whenever you are vibrating, the form will get disturbed, and you have no noticed, and there is no supervision at all. So what happened when you are putting the concrete and it get hardened, the section becomes some the undulation in the section. So the design, the load for it is designed it will not be carrying that load actually, because of the extra movement are coming, extra eccentricity are coming, because of the irregularity in the sections. Okay, so these are the few points, and very it is actually the two type of engineer is there. One is the design engineer, and one is the this building engineer. Step by step, actually they're implementing the design in the site. So uh, the two category of engineer is there. Okay. Actually, in design engineer, they are saying that this provision from the exterior, exterior position, or the from the end of the building, edge of the building, this gap should be maintained uh, when you are casting. So they have the blueprint, and they make the sketch, all are things. However, when you are placing the concrete, the several others, many other obstructions are coming. So that that is the building engineer have the duty, or has should have that expertise, should have that expertise or a potential to find out some solution, so that the design profession or um, design aspects and parameters are implemented accurately. So their duty to implement the design to uh, the constructions. So two categories are there. So as general guidelines, maximum permissible free fall of the concrete may be taken as 1.5 meter. This is 1.5 meter. 1.5 meter means 1.5. Okay. Yes, 1.5 meter actually. And so 1.5. So 1.5 actually no answer are matching with it. This idea and the no answer are matching. So 25, 50, 100 centimeter, 250. So in that situations, what you do, you just choose the closer value. Whatever value you are, you know, that this is the right value, this is the right value, and this should be there. And you are not getting in any of the four options. Then at the time of examination, you will just choose the closest one. So the closest one is the actually, uh, yes, the closest one is 100. This is the irony. You understand? Now, the main objective of the compaction of the concrete is to eliminate the air holes, to achieve maximum density, to get intimate, intimate contact between concrete and the embedded material. So all options are correct. You are vibrating. The purpose of vibrating, you are extracting the air out of it to achieve maximum density. Okay, so all options are correct. The steam curing is not used with ordinary Portland cement, rapid hardening cement, high alumina cement. And so it says as IS IS 6452 2000. The compound that high alumina, uh, the high alumina cement is mainly a refractory cement. In the view of the above and other properties of the high alumina cement, there are certain restrictions given below about the use of the cement in the concrete, which should strictly follow the following strictures. In the view of retrogression in strength and reduced durability, means strength, some deterioration in strength and reduced durability, high alumina cement shall not be used in locations where the ambient temperature are likely to exceed 18 degrees Celsius, even for short period. and it shall not be used in mass concrete in the view of heat, high heat of hydration, including conversion of the hydrated compounds. Accelerators like calcium chloride shall not be used in cement. Steam curing and elevated temperature. Steam curing or elevated temperature of the curing shall be avoided. Steam curing or elevated temperature curing shall be avoided. High alumina cement shall not be mixed with the any other cement. The high alumina cement shall not be mixed with the any other cement. Okay. So what it says, this is steam curing is not used in ordinary Portland cement, rapid hardening, high alumina cement. So this thing is high alumina cement. Okay. So these are the options. So mm, for the high alumina, actually this IS 6452 stated the how where you can use how the high alumina cement can be used and cured. So these are the points. So the accelerator, you can't use the calcium chloride accelerator, high aluminum cement, and steam curing. So I'll just point out the point. So high this high aluminum cement is high aluminum cement. High aluminum cement is mainly refractory cement. It is mainly refractory refractory cement, refractory cement, and certain strictures are there. First option, in the view of retrogression strength, durability, high aluminum cement shall not be used in location where ambient. It should not be used. It should not be used considering the durability and strength consideration. It should not be used. It should not be used in locations where the in locations where the ambient temperature at the ambient temperature is more than 18 degrees Celsius, even for a short duration also. Even for a short duration, you can't expose for a short duration. It shall not be used in mass concrete. This I mentioned it shall not be used in mass concrete. Third, there is mass concrete in the view of high heat of hydration. Because in mass concrete, we don't prefer high heat of hydration. Okay, and if the high aluminum cement use, it may increase the heat of hydration. Okay, an accelerator like calcium chloride shall not be used in the cement. Calcium chloride shall not be used. Fourth, steam curing and elevated temperature of the curing shall be avoided. Steam curing or elevated temperature curing shall be avoided. Fifth is the high aluminum cement shall not be mixed with any other type of cement. The high aluminum cement shall not be mixed with any other type of cement, with any other the type of cement. Now, this 106th question. It is high aluminum. So for satisfactory workable concrete with a constant water cement ratio, increase in aggregate cement ratio. What happened? Increase in strength, decrease in strength, no effect on strength. Increase in strength, increase in aggregate cement ratio. Sorry, increase is aggregate cement ratio for at a given water content. Increase in aggregate cement ratio produces a lean and harsh concrete with poor finishability. So it says that increase in with given water content, water cement ratio, water content, increase in aggregate cement ratio, aggregate cement ratio results lean and harsh concrete. Harsh concrete. No plasticity is there. Okay, with poor finishing, with poor finishing, with poor finishing. Hence, the strength will get reduced. Hence, the strength will get strength will get reduced. Okay, so this is strength. Decrease so actually mm, increase decrease in strength, decrease in strength. Yeah. Now, addition of sugar in the concrete results. What it results? Sugar in is a retarding admixture which delays the setting time. A high concentration may permanently prevent the final setting and further hardening of the concrete. Okay, so it is the retarding admixture. So increase the setting time by 1 hour. These are the things. So there is no big deal about it. So increase the setting time by about 4 hours. So aggregate impact value, the aggregate impact of a particular aggregate used in building concrete is less than 45 dot pavement concrete is less than 30. Okay, so I think it's more the value impact value is passing, how much is passing from the aggregate after crushing. So more the value, I think it's less the is bad aggregates. So more the value is not a good aggregate. So I think it is 8. 8 to what it says? D. All options are correct. So these are the options you can check any stage put it is available. So all options are correct. Building concrete is less than 45, or building concrete is less than 45. Pavement concrete is less than 30. Runway concrete is less than 30. Okay. Yes, obviously for runway, this the fine should not be after crashing. The fine should not be much more. However, in building construction, we allow this fines after get crushed. So you can check the what are the test procedure, and you can identify the what is the impact value, the percentage passing to the what percentage you are giving to the ship. I think this ratio it gives you some percentage value. Okay, so more the passing means after it crushed, it is a bad aggregate. quality is not good. So for the runway purpose and high payment purpose, where there is a frequent movement of vehicle or in the runway, there's a friction is very much and its impact is higher when you just take down to airport, then that impact is very high. So it should hold that impact or have the strength to carry out that impact load. Okay, so the 109th question. The compressive strength of 100 mm cube as compared to 150 mm cube is always less, more, equal, none of this. Is less, is actually more. Actually, whenever you are testing it's a small size if um, small concrete blocks, it become more compact and you are giving more load. So what is the size of the cube is decreased if the size of the cube is compressive strength tend to increase. And in another way, you can get that idea. If this size is less, then paste content is much less, and if the paste content is less, and this aggregate are more coarse aggregate are more closer enough to make the particular grade. So if the aggregate actually if the concrete paste, if you check the each and every element, the aggregate is most strongest and elastic value is maximum among the other components, cement and mortar, cement, sand. Okay, so this finds. So this is a high, and if they're concentrated and they are at close to each other, they give the high strength. So that is natural. So it is more. So that is the approximate approximation ratio of the strength of the cement of concrete of 7 days to that of 28 days. Approximate ratio of strength of cement concrete to of 7 days to 28 days. What is the ratio? It's 110 question. 7 days concrete it is 2/3 of 28 days. 2/3 means it's actually 2/3. 7 days strength F7 is 2/3 of F28. So it is closely. Again, the same scenario is coming. It is B, close value. Durability of the concrete is proportional to sand content, water cement ratio, aggregate ratio, cement aggregate ratio. Aggregate ratio. Let's check what is durability is cement aggregate ratio. Yes, there should be some sufficient cement and aggregate also there. So durability concrete can be increased by increasing the cement aggregate ratio and decreasing water. So water cement ratio if you decrease, then the strength will be get enhanced. Strength will get enhanced and durability will be much more. So D will be much more. Okay, decreasing sand content. Decreasing sand content, durability will be more. Okay, and decreasing fine to coarse aggregate. And fine to coarse aggregate is fine aggregate to coarse aggregate. Uh, if you check decreasing the fine to coarse aggregate, the durability will be more. Okay. Uh, yes. And now cement to aggregate ratio, if cement to aggregate ratio is increased, then durability will also increase. Young's modulus of the cement EC is given by 5,000 root FCK. I think initial tension modulus 2 B. And low temperature during concrete laying increased strength, decreased strength has no effect on strength. I said B, low temperature during concrete laying decreases strength and it reduces the rate of hydration. Actually, low temperature, if the temperature is not cold environment, the appropriate temperature is not getting, the heat of hydration will not be sufficient as it should be with the particular ambient temperature. Okay, so these are the criteria. So decrease. Water cement ratio is generally expressed in volume of water per 50 kg of cement. It should be 50 kg. Yes, 50 kg. Water cement ratio is generally expressed in volume of water required by 50 kg of cement. 50 kg. The entrained air in the concrete increase the workability. It says entrained air in the concrete reduces the tendency of the bleeding and segregation, improves traceability and early finishing, thereby improve the workability and just improve the property of lean and mixed concrete and lean and harsh tendency. Okay, so these are the improvements. So 116, the Poisson ratio for the concrete increases with richer mix, decreases with richer mix, and remains constant. None of this. The Poisson ratio means the Poisson ratio for concrete increases with the richer mix. Rich mix means the appropriately designed mixed. Okay. Uh, for rich mix, the ratio of cement to aggregate is high. For rich mix, uh, cement to aggregate ratio. Cement to aggregate ratio is high. Cement to aggregate ratio high, and hence the Poisson ratio would also increase. So this is A, increases with richer mix. The that test most suitable for concrete of very low workability. Very low workability, I think very steep concrete. I think compacted factor test. Maybe time is very compacted factor test is right option. It should be. No, it's a VB test. I just mix up with the AK. Actually, very low slump. Slump test we give the approximately zero slump. Very low workability. Zero slump would be giving. Also, compactive factor is applicable for very high slump value. Actually, compared to slump test, it shows a more it test more steep value. Hence, the VB time is suitable for the very low slump. So VB time. The strength and quality of the concrete depends upon all above. The aggregate shape, aggregate grading, surface area of the aggregate is all of the above. Aggregate shape means the packing density. The rounder shape, more the packing is higher. So we have already started this thing based on the angularity, it giving much strength. And much bondage is much there. Okay, with the paste. If it is round, it is not get bonded. The round shape. Aggregate grading is in it is not particularly poorly graded. What happened? The small interstitial faces space will not get filled by the paste. It will remain void. Okay, it will remain a void space or empty spaces. The surface area of the aggregate surface area is surface area surface area is more. The specific surface area aggregate size is more. So the specific surface area uh, is less. Okay, so if the specific surface area is less 6 by d, if the size is more, the specific surface is less. If you check the 6 by d formula, if the size is more, the specific surface is less. If the specific surface is less, then the water requirement for the hydration is also less. Then it will not get the proper heat of hydration. It will not get the heat of hydration. And further, if the area is a larger aggregate, then there are also the cracks will start to propagate along the edges because of this wall effect and other effects. These are the very relevant points. Now, next question is M10 grade of concrete approximates this that what is mixed proportion. 1 on 2, 136, 1 to 4. It should be, I think, 1 to 4. Let's see. Actually, 7.5. This is better. I write it. M 7.5 is 1 is to 4 is to 8. M10 M10 1 is to 3 is to 6. First option is cement. Second is the coarse fine aggregate. Last is the coarse aggregate. That's M15 1 is to 2 is to 4. M20 1 is to 1.5 is to 3. So these are the things. Now process of proper and accurate measurement of the concrete ingredient for uniformity of the proportion is called grading. So it is 1 is to 3 is to 6. Hmm. The process of proper and accurate measurement of the concrete ingredient in uniformity of the proportion for uniformity of the proportion is called actually batching. Sorry, it's called batching. 128. Pick up the correct statement from the following. 121. What is it? Insufficient quantity of water makes the concrete makes the concrete mix harsh. Is the insufficient quantity of water makes the concrete unworkable. Excess quantity of water makes the concrete segregated. See, all options are correct. Yes, all options are correct. Pick the incorrect statement from the following. A rich mix of the concrete possesses high strength than that a lean mix of desired workability with excessive quantity of water. Strength, we have to find out the incorrect one. The strength of the concrete decreases as water cement ratio increases. Is good also right. If the water cement ratio is less than 0.5, 0.45, the concrete is not workable and causes honeycomb structure. As a value, I don't know actually. This is what is the particular value. So it says that the good, and lastly, there's the good compaction by the mechanical vibrator increases the strength of the concrete. Yes, vibration means if you are vibrating more, the water will get it will become more dense, and what the air will get out of the concrete system, make it more dense. So it says that a rich mix of concrete has high cement content. Okay. The high fine content, fine cement content, high fine content, which makes the mixed concrete harsh. Hence, it is not necessarily true that rich mix of concrete would produce higher strength than the lean mix of desired workability. So it is not necessary that this rich mix concrete high cement content is fine. The higher cement content is a right choice, but however, this possesses higher strength, we can't say. Actually, rich mix in terms of workability, in terms of, so we define the richness, we define the how it will behave. So we engineered it. So and we call it a rich mix. So it may not be the strength. Okay. That is high performance concrete. The high performance concrete, self compacted concrete or the high strength concrete is one high performance concrete. The strength is our criteria, high performance. But all high performance concrete is not the high strength concrete. Okay, so performance is we are defining the performance criteria. We are defining in terms of strength, we are defining in terms of workability, and so on. Pick up this, it is pay. Now the pick up the correct statement from the following. It says that the concrete gains strength due to hydration of the cement. Concrete cured at temperature below the 23 degrees Celsius, 23 degrees Celsius gain the strength up to 28 days. Concrete does not sit at freezing point. So at freezing point, what happened? Um, and what happened? The hydration become much slow. It not get hydrate, so it will not set. Is true actually. The concrete cured at temperature below 23 degrees Celsius gain strength up to 28 days strength. Actually, this I have no information. Not sure. That the concrete gains strength due to hydration of the cement. So this A, C are true. I not about. I don't know about B. Just to check. Actually, it should be B. Actually, so all options are correct. So the concrete cured at a temperature below 23 degrees Celsius gain the strength up to 28 days strength. So all options are correct. So pick up the correct statement from the following. 100 to 24. Higher workability indicates unexpected increase in moisture content. Higher workability increases indicates the deficiency of the sand. If the concrete mix is dry, the slump is zero. All options are correct. The higher the workability indicates the unexpected increase in moisture content. Maybe it is true. Higher workability indicates the deficiency in sand. So actually, this all options are correct. So incorrect options are said, right? So higher workability indicates higher unexpected increase in moisture content is right. Higher workability indicates the deficiency in sand is also right, and is mix is dry, the slump is zero. Yes. Now top dia, bottom dia, and height of the slump. What are the mole? So 10 to 30 20. I think this not 10 20 30. It should be 10 20. Let's see what it is. Is A. Is A. Oh, fine. The pick up the correct statement of the following. The segregation is necessary for a workable concrete. Consistency does not affect the workability of the concrete. If the slump increases, the workability decreases. And the third statement is not true. 126. Oh, the nine of this is that the segregation is necessary. Segregation is necessary for a workable concrete. No, workable concrete doesn't mean that the segregation should be there. Consistency doesn't affect the workability. It's consistency affect the workability. So none of the options are correct. So the grade of the concrete, the grade of the concrete M15 means the compressive strength of the 15 centimeter cube after 28 days is 15 MPa, right? 15 MPa. 15 MPa means Newton per meter square. Newton per meter square, right? So Newton means if I just 15 Newton per meter square, you just calculate it 50 Newton. I'm just making a mass of it from it. So I just divide it by 10. Is mg. 1.5 centimeter square. So 1 meter is 100 centimeter. And millimeter means millimeters means 10 centimeter, 10 millimeter, 1 centimeter. Okay. So into 10 square is coming 150. 127 is B, is correct. 150. It is nothing. It's nothing. Mm. It's 150 or 15 15 Newton per meter square, right? Mm square MPa. So I'm just converting Newton to this is mg, this Newton by I'm dividing 9.9 Newton by 10. Okay, so it will make a kg of it. Okay, so better I can write here divided by 9.81 or 10 will become kg. Now millimeter is 10 square centimeter. It will go up, 10 square will go up and it will form 150. So this is so preliminary test is repeated if the difference in compressive strength of the three test specimen exceeds 5%, 8%, 10%, 15%. As per 15.4 clause. What it says 15.4 clause? Okay, so it says that the test results of the sample shall be average of the strength of the test specimen. The individual variation should not be more than plus minus 15% of the average. If more, the test results of the specimen are invalid. So you have to repeat this test again. It says that individual variation should not be more than plus minus 15% of the average. So it's T. 129. The under normal condition using ordinary cement, the period of removal of formwork is 7 days from actually these are charts are available. 7 days for beam soffit. Beam soffit means this is the beam. This is the beam. Here the framework. What is the framework? This framework. This is soffit framework. Removing this framework is called the soffit, beam soffit. So this bottommost portion. The 7 days for beam soffit, 14 days for bottom slabs of span 4.6 meter and more, 28 days for bottom beams over 6 meter span. Actually, IS 456 has recommended this all the provisions. What is the for vertical formwork to the columns and walls and beams? It is 16 to 24 hours. Soffit framework to the slab, props to be refixed immediately after removal of the formwork. So it's 3 days. Is beams soffit of the soffit framework to the slab is 3 days. Soffit framework to the beam, it's actually 7 days. So it is correct. So props of the slab. Props means this the supports. Props of the slab. One category is spanning. When spanning means this shorter direction. Spanning, not the longer direction. When the slab is spanned, so it's always says the short direction, short dimension. Spanning up to 4.5 meters is 7 days. Spanning up to 4.5 meters is 7 days. spanning over 4.5 meters is 14 days. Or props to beam and arches spanning up to 6 meters is 14 days. Spanning over 6 meters is 21 days. So 28 days for the bottom beams over 6 meter span. It is correct. 14 days for bottom slabs of span 4.6 meter and more is 14 days. So 129 is, it should not be spanned uh, more than, it should be more than 44.6, not including 4.6. It is, if it is 4.6, then it is 7. So all options are correct. For given water content, workability decreases if the concrete aggregate contains an excess of thin particle, flat particles, elongated particles. All of the options are correct. So actually it is B. Due to presence of thin, flat, and elongated particles, the surface area increases. Hence, more water is required to weight the surface area. Therefore, the same water content, the workability decreases if the concrete aggregate contains excess of this particle. So flat, thin, and elongated particles takes more water. So previously, what do you add what we are adding in the water? What the with the available water content? If this type of particles are introduced, then the available water content will be less for the proper hydration or for the proper reactions. And then what happened? Their workability will be less. All options are correct. So for ensuring quality of the concrete, use single size aggregate, two sized aggregate, graded aggregate. Obviously, it should be graded aggregate. Proper grading of the aggregate will ensure proper packing of the concrete, which in turn led to better strength, workability, durability, and water tightness and better quality of the control. So denseness should be there. The graded aggregate. The graded aggregate is right. Okay. So according to IS 456, number of grades of the concrete means how many grades are there? 132. The table 2, the group categorized as ordinary concrete, standard concrete, and high strength concrete. So okay, so I think it is 3. Standard, I think that with that other standard deviation also mentioned. Okay, so 132 is 3. Standard concrete, table 2. Table 2 is there, and standard concrete, ordinary concrete, OC, standard concrete is C, and high strength is C. The risk of segregation is more for wetter mix, larger proportion of the size of the aggregate, coarser grading. All options are correct. So all options are correct. It's very it. I think it should be all options. No, no, actually, this risk of the segregation is much more for wetter mix. Means when the mix is much water is content is much more, then risk of segregation is much more. Larger portion of the maximum size of aggregate is these are not relevant reason. So weight and mix is the right one. So after casting in ordinary cement, uh, but after casting an ordinary cement concrete on drying, expand, shrinks, mix, or none of this. On drying, it's already it shrinks actually. 134 it's C. 134 an ordinary concrete on drying shrinks due to loss of water due to evaporation. Shrinks due to loss of water. Permissible compressive strength of M30 grade concrete. Now again, you have to convert it in 30. You are dividing by 10 is 3. Now you are including 10 square. It is 300. Sorry, 300 is permissible. I think I'm doing some mistake. Permissible strength, right? So actually, permissible strength it is characteristic strength. So permissible strength is the by factor of safety, sigma CBC. Don't mess up with this. Actually, these questions are asked for the student fall to their tricks. So be please be careful about those tricks. So actually, there are some payers provision was available for the sigma CBC. Sigma CBC is the allowable, or it is a characteristic strength, right? So sigma CBC is some factor of safety are there. So it is about 3. The sigma ST also there. Okay. So sigma CBC equal to sigma this F character FCK by 3. See again, it is also available in IS 456. It is 100. Now 136. Curing reduces the shrinkage of the concrete, preserves the property of the concrete, prevents the loss of water by evaporation. All options are correct. It should be all options correct. Let's see what they are saying. Yes. Curing, all options are correct. Reduces shrinkage of concrete, preserves properties of the concrete, prevents the loss of water by evaporation. All are correct. Proper proportioning of concrete ensures desired strength and workability, desired durability, water tightness of the structure. All options are correct. A proper proportioning of the concrete ensures desired strength and workability. Okay. Proper proportioning, desired strength and workability is correct. Desired durability is also right. Water tightness structure is also right. So all options should be correct. No, actually it says proper proportioning. Actually, I'm mixing. I'm thinking that durability may be the maybe contributing the strength and workability, because these are the different properties. So desired strength and workability, it comes from proper proportioning. So this is the first option. Proper proportioning of the concrete will ensure proper packing. Yes, proper proportioning, proper packing of the concrete, which in turn lead to better strength and workability and durability. Actually, this workability and durability are coming as result. The cause is the proper proportioning. Proper proportioning of concrete will ensure the proper packing, and which in turn lead to better strength, workability, durability, water tightness. Actually, all our tightness is however it says A, but it is not A. It's just I'm right actually. It's their statement is like that proper proportioning will ensure proper packing of the concrete. Yes, packing of the concrete, which in turn lead to the better strength, workability, durability, and water tightness. So all are there. So it should be all, but it says 1. So you should not be blindly, you should not blindly follow the answers. So while compacting the concrete by mechanical vibrator, the slump should not exceed. The slump should not exceed testing C. So as per CPWD specification for concrete works, concrete Concreting lightly reinforced section, reinforced section with vibration slump is up to 25 millimeter. Lightly reinforced section, lightly reinforced section, slump is 25 millimeter. Slump is 25 millimeter. Concrete heavily reinforced section, vibration with vibration. If you are vibrating it, the slump should not exceed more than slump should be 25 to 75 mm. It should not exceed. It should be in between for 20 mm aggregate for MSA or 20 mm aggregate. Should not exceed 25 to 75. Now, yes, these two things are there. So comparing mechanical by mechanical vibrator, slump should not exceed what? 25, 2.5 centimeter, 5 centimeter, 7.5 centimeter. So should not exceed, because there is no specification that uh, whether it is lightly reinforced section or heavily reinforced section. It's not mentioned. So it says it's C actually. So they are saying that they consider, they are taking this question as it is heavily reinforced section. So heavily reinforced section, it should not exceed 77.5 centimeter. So obviously it should be in between 25 to 75 millimeter. So what is the minimum period for which the lime concrete in foundation be left wet without start of masonry work over it? So minimum time required for concrete, for lime concrete in the foundation left wet. So lime concrete foundation, uh, so we should keep the concrete as it is, and afterwards we should start our work of machinery work, start our machinery work. So what is the delay time? So the specific values there no. Actually, in case of lime concrete, curing should start keeping by keeping the concrete damp with moist gunny bags or sands. And after 24 hours of its laying, and after 24 hours of laying, and should be continued for a minimum of 24 hours. Um, uh, you have to wait it for 24 hours, 24 cross 7, continued for a minimum period of 7 days. Okay, so curing should start. The curing should start after 24 hours of its laying. After you lay the cement lime concrete, after from the time you complete the laying of the concrete, from that time after 24 hours, you start curing it. It will set in between curing it, and it should be the curation duration is the 7 days minimum, and afterwards the machinery, you can start the machinery work. Is 7 days. What is the characteristics of the M15 grade concrete? It is 15 Newton per millimeter square. It is all true. This M for mix, 15 is the strength, characteristic strength. In case of reinforced concrete, what is the minimum grade of concrete that should be used in seawater? This is very a common question. M20 or M25 or 30? If it is plain concrete, I think it's 30. I should be seeing that in the thing, IS 8.2.8. Plain concrete is the grade reduced. If the reinforcement is there, the grade increased at 8.2.8. Yes, concrete in seawater, concrete in it's seawater. So it IS 456 clause 8.2.8. So concrete in seawater or exposed directly along the sea coast shall be at least M20 grade in case of plain concrete, M30 grade in case of reinforced concrete. So it is for plain concrete, it is for reinforced concrete, M30. 42. Curing of the concrete can be done by spraying, ponding, covering with moist cloth, any of this. So all options are correct. Strength of the concrete is directly proportional to cement water ratio, sand cement ratio, water aggregate ratio, all of the above. 143 is A, cement water ratio. You have also some plots. You can check strength or cement water ratio. Water cement ratio is here. If it is reversed, then it's just it is reversed. The curve get reversed. So it is keep on increasing. Now 144. Which of the following factors influence the durability of the concrete? Cover of the embodied steel, cement content and the water cement ratio, shape and size of the member, all options are correct. So it's obviously all options are correct. So less the cover of the embedded steel, more the steel is susceptible to corrosion. More the cement ratio, water cement ratio, more the porosity it will have. It's more vulnerable for ingress of chemicals. And the thinner the sections of the material, more susceptible to chemical attack. So these are the thing, all the things. Embedded steel means water can ingress, water can ingress. Water cement ratio is much more, the porosity is much more vulnerable to ingress of chemical, and cover is less corrosion. So it is corrosion. It is corrosion. Water ingress. Second option, water ingress. Shape and size of this member means uh, a chemical attack will be there. Chemical attack. Chemical attack. Okay. Chemical attack. All options are correct. So lowers water cement ratio, concrete produces more density, small creep and sinkage, more bond. You see, actually it's a lower water cement ratio, less porous concrete will be, and hence the it is more dense. Less porosity means it's more dense. Less porosity means it's more dense. Similarly, less water will lead to less shrinkage and creep. More water, the creep will be much more, and less water, creep less, and this less shrinkage and better bond. All options are correct. The strength and quality of the concrete depends on aggregate shape, aggregate grading, surface area of aggregate. All options are correct. See, all options are correct should be. In angular aggregate gives the better interlocking. Angular, and then this angular aggregate gives better interlocking. Better interlocking characteristics. Okay. Better aggregate grading gives better strength and dense packing. Better aggregate grading gives strength and packing. And more surface area of the aggregate, more hydration, less workability. More surface area, more hydration, more hydration. The approximate ratio of strength of cement concrete at 3 months to that of 28 days. 7 days, I think, 2/3. So 3 months, what is the ratio? 3 months, it says A 1.15. So strength of 3 months, strength 28 days strength 1.15 to 1.15 times 28 days strength is the strength at 3 months. The air entrained air in concrete increases workability. Repeated question. Well, obviously the porosity will much more. The air entrained in form of bubbles provides frictionless or in foam the frictionless process in compaction, and the workability become higher. Okay. So now 149, to produce impermeable concrete, thorough mixing of the concrete is required, proper compaction of the concrete is required, and proper curing of the concrete is required. All options are correct. Impermeable concrete, through mixing of the concrete, proper mixing is also correct. Proper compaction is also true. Proper curing is also true. So 149 says that yes, it's D. To thorough mixing, proper compaction required. To thorough mixing and proper compaction required, compaction required, so that ingredients of the concrete become more densely packed. Proper curing is required so that the process of hydration continues for a longer period of time, so that more products of hydration are formed which can fill the voids. Okay, so with the time, proper curing gives the more hydration product. If the more the hydration product, more that gel gel formation, more bonding is there and more strength. Okay, I think it is already 8:30. So if the all other questions are also there, so as I think in the coming semester I'll be taking this course. I think I'll be taking this course. Let's see what happened the time, what it tells. And however, whatever the question I covered in this session, I'll try to upload in the our portal, our which yeah, that Teams. You will get an handout on it. So I'll try to add some extra question along with the answer, probable correct answer. So please go through this question, and best luck for you guys. Thank you for joining in this evening. Thank you, Abdul. Only one is evening.
Okay. Thank you. Good night.
Good night.